Good evening, Commissioners. I'm Allison Reynolds with Stoll Reeves, and I'm a land use attorney for the applicant Georgia-Pacific. We appreciate the opportunity to present the project to you this evening and respond to questions raised during the previous hearing. Also with me today are Don Dotson and Christy Dutman, both with engineering firm Wood PLC. Don will be presenting on a seismic evaluation and mitigation at the site, and Christy will be presenting information about the sludge material that commissioners requested. Before we explain the more technical aspects of the application and address your previously submitted questions, I would like to introduce CJ Drake, who is the Public Affairs Manager at the Georgia-Pacific Containerboard Mill in Toledo. CJ will provide some brief background on the mill's history and operations.
Good evening. I'm CJ Drake, Public Affairs Manager at the Georgia-Pacific Containerboard Mill in Toledo, and I've worked here since August 2015. I'm pleased to present this recorded testimony in support of our conditional use permit application. Because of the mill's close proximity to the city of Toledo, we must always be mindful of the impact of our operations on the people who live here. We must earn and never take for granted the right to operate in Toledo and Lincoln County. Here's some background on the Toledo Mill. We have been a proud partner in Lincoln County's economic progress since we began operating here in 1958. The product we make is containerboard, which is the brown paper and packaging boxes that are used by millions of consumers every day. The mill employs about 360 people on an annual payroll of approximately $45 million. We are also Lincoln County's biggest taxpayer, and our current tax bill is more than $3.3 million. The county's second largest taxpayer pays less than half that. The mill is a 24-hour-a-day, 7-day-a-week operation. We produce about 2,600 tons of containerboard every day. Our product is shipped by truck and rail to factories across the nation for conversion into boxes, many of which are used to package food products. We are the leading recycler of old corrugated containers and pre-consumer box trimmings on the West Coast, currently recycling 450,000 tons a year into new containerboard. The project that's the subject of the application you are considering is of high importance to the mill, and without it, we cannot operate efficiently or competitively. Allow me to clarify a few important points about the project. First, we wish to make it clear that the project does not involve the disposal of toxic waste, human waste, household garbage, mill garbage, or biosolids. Second, the project area has been used for the same purpose for decades. What we are proposing is entirely consistent with the area's historic and current purpose. Finally, everything we do and plan to do is permitted and regulated by various government agencies. For example, our wastewater treatment system is governed by our National Pollutant Discharge Elimination System permit and our solid waste permit, both of which are granted by the state. We've engaged consultants, engineers, and experts, and we've invested a lot of time and resources into identifying the best way forward. We've discussed a few options and alternatives to this project, none of which is practical or effective. One option is the possibility of hauling this material to an off-site landfill. As we previously explained to you in writing, this alternative would not require county approval. In order to serve the same purpose as the project, the same 700,000 cubic feet of material that the project would dispose of on-site would need to be trucked off-site to the nearest landfill that could handle it, which is in Corvallis. This would require approximately 50,000 round trips made by trucks traveling 100 miles per trip. As the industrial hub for Lincoln County, Toledo experiences heavier truck traffic than most communities in the region. Such traffic is consistently and historically one of the leading concerns expressed by residents and public officials who represent the community. Just as significant would be the increased carbon emissions released into the environment from such traffic. It's indisputable that this offsite trucking alternative would aggravate those concerns. Therefore, in the interest of being a good neighbor and out of respect for the environment, we strongly prefer the project to the undesirable alternative of hauling the material offsite. After much study and analysis, it's our position that the project for which we are seeking approval is the best option for everyone, the mill, the community, and the environment. In that spirit, I respectfully encourage you to support the application. Thank you for your consideration.
Thank you, CJ. To begin with my part, we want to orient the commissioners to the site. This image shows the site as it exists today. This is GP's mill on the east side of the river and within the city of Toledo. These are wastewater treatment ponds associated with the mill. This is GP's existing industrial landfill area, which is within the county and on the west side of the river. This is the 30-acre settling pond, and this is the 15-acre settling pond, which is the subject of our application today. This aerial image shows where the proposed project will be placed on the site. This is the 30-acre settling pond, which will not change from its current configuration. Commissioners asked about the separation berm shown in the 30-acre settling pond in our original materials. That will not be added as part of the project, and we've corrected that in the record to show this pond will remain as it is today. This wet area here is the remaining portion of the existing 15-acre settling pond. This area is the new cell where materials removed from the settling ponds will be stored in dry form. To answer questions raised by commissioners, we want to also explain the purpose of the project. The mill uses water to create container board from a combination of recycled fiber, such as old corrugated containers, and wood chips. After the water is used, it is sent to a wastewater treatment area adjacent to the mill that utilizes a series of basins and treatment technologies to clean the wastewater. A major element of the treatment process consists of separating solid residuals, the small wood and paper particles, from the water before the cleaned water can be discharged. The solid residuals build up in the treatment basins over time, requiring their removal roughly every 3 years. This periodic basin maintenance is accomplished by sending the material from the basins to the 15 and 30-acre settling ponds, where the solids settle out from the water. Once the solids settle out, the water is returned to the basins before ultimate discharge. The settled material, referred to as sludge or settled solids, accumulates over time in the 15 and 30-acre ponds. Eventually, inevitably, these settling ponds reach a critical solids level where the saturation of solids in the ponds is too high to allow effective separation of the solids from the water, which is what's beginning to happen at GP's facility now. This situation has occurred through GP's normal operations at the facility and is not due to an increase in production or any changes of mill operations. To date, GP has been able to maintain adequate volume within the 15 and 30-acre ponds by dispersing the settled solids within and between the two ponds to ensure continued operation of the mill's wastewater treatment system and associated basins. However, the volume of settled solids in the ponds will very soon reach a critical point, which is why GP is proposing this project. Given that the issue before GP is that the settling ponds will soon run out of capacity to handle more solids, it may seem counterintuitive that GP is proposing to eliminate some of its pond area on the site, since this will decrease the overall settling pond capacity. However, this solution works because the amount of solids that can be stored in an area when dry far exceeds the amount of solids that can occupy the same area when the solids are within a pond. By converting a portion of the 15-acre pond area into dry storage, the project actually creates more functional capacity in the ponds during the 50-year project timeframe. We also want to touch on the regulatory framework for the project, since there were some questions from commissioners. The 15 and 30-acre ponds are part of GP's overall wastewater treatment system and were authorized several decades ago. DEQ regulates the treatment system, including the ponds, under its wastewater permitting program, and today storage of the wet settled solids within the ponds is regulated under the mill's DEQ wastewater permit. GP's current proposal, however, is to store these same settled solids in dry form on the site, outside of a pond. When GP approached DEQ about the proposed change, DEQ determined it would regulate the settled solids in the new storage area as solid waste by adding a cell to the existing landfill, which DEQ also regulates. Importantly, whether under DEQ's wastewater program or DEQ's solid waste program, the agency ultimately will maintain regulatory oversight over the project's design and implementation, and thereby ensure it poses no risk to human health or the environment. As a prerequisite to DEQ modifying GP's existing landfill permit to add the solids area, DEQ requires us to obtain local land use approvals first from you. However, permitting from DEQ must also be completed before the project can ultimately move forward. We also think it's important to discuss the alternative. What happens if GP cannot move forward with the project as it's proposed? If the project is not approved, GP could instead transport the settled solids offsite to the closest existing solid waste facility that is permitted by DEQ to accept this material, which is in Corvallis. This alternative would not require county land use permits and would not fall under this commission's jurisdiction. To provide the same operational capacity as the project, 50 years of pond operations, the same 700,000 cubic feet of settled solids that the project would handle on-site would instead need to be trucked to the Corvallis landfill. This would require approximately 50,000 round trips made by trucks traveling 100 miles per trip during the 50-year project period. This offsite alternative to the project would still require removal of the settled solids from the wastewater treatment ponds, which will include some of the same potential for noise, odor, and visual impacts as the project, and would leave the existing 15 and 30-acre ponds, which contain settled solids and water, in place adjacent to the river. As CJ explained earlier, the project will avoid the significant traffic and carbon emission impacts associated with offsite hauling, and therefore is a strongly preferred alternative for the environment and the community. I'll now turn this over to Christy Deitman with Wood to discuss a further evaluation of the solids material that we put together in response to the Commission's questions.
Wood collected samples of the settled solids for laboratory testing of 8 metals and 19 chemical substances known as polycyclic aromatic hydrocarbons, or PAHs, that are likely to be present in settled solids. PAHs are typically produced from incomplete combustion of wood or other fossil fuel sources and can be found naturally in the environment, as are metals. The samples we collected were from multiple locations and depths across the ponds to evaluate the solids that have accumulated in the 30-acre pond over time. We compared the detected metals and PAHs in the settled solids against published human health and ecological risk screening criteria. The human health screening criteria were selected to evaluate the settled solids in its current disposition upland. And the ecological screening criteria were selected to evaluate a hypothetical release of the solids to the river. The PAHs that were detected do not exceed the occupational and construction worker levels, meaning they do not pose a risk to anyone working in or around the solids. The concentration of benzoatrazine at one sampling location slightly exceeded residential leaching to groundwater levels. However, the existing ponds include a protective clay lining to prevent releases to groundwater. This liner will remain and protect against any leaching from the settled solids area. No individually detected PAHs exceeded the most conservative published state of Oregon ecological risk screening criteria, which could be applied to ecosystems found in the river. Metals were detected in all the samples we analyzed. The detected metals are also naturally occurring in the soil and in the trees used to manufacture pulp. And we compared the levels we detected in the settled solids to the state of Oregon published background concentrations for the Coast Range soils. For the most part, the metals we detected were below the naturally occurring background concentrations for human health. However, lead detected in one sample exceeded the background concentration, but it did not exceed the applicable occupational and construction worker receptors. In some samples, lead exceeded the levels for leaching to groundwater. However, this does not actually mean that lead will contaminate groundwater during a release. We conducted additional testing to determine if, during a release, lead could actually leach to groundwater. These additional tests show that levels of lead that were capable of leaching to groundwater are non-detect. Arsenic, cadmium, chromium, lead, and mercury exceeded the most conservative published state of Oregon screening values in one or more samples for a freshwater setting. So a theoretical release of solids material to the river could potentially result in minor adverse effects to invertebrate benthic organisms. However, as the GP team will discuss through the presentation, the project involves several protective measures and mitigation to ensure that the settled solids will not ever enter the river or groundwater. The project is designed to safely store the solids in a solid waste cell designed for this exact material. With these protections incorporated, the project does not pose a risk to human health or ecological receptors.
Thank you, Christy. Next, we want to discuss the protective measures Christy alluded to that are included as part of the project and ensure that the settled solids will not reach groundwater or the river. Groundwater is protected from contact with the solids by an existing clay lining in the ponds. GP will retain that lining in the storage area. The lining prevents any moisture that could accumulate in the solids from infiltrating groundwater. Groundwater monitoring wells at the site, shown here, are routinely sampled and analyzed to ensure there is not contamination from the ponds or the existing landfill, and this monitoring will continue on the site. Stormwater that runs off of the storage area will be captured by the site's extensive drainage system and sent back to the wastewater treatment area. The berm is an additional physical barrier between the solids and the river and prevents runoff water from reaching the river. Next, we want to address commissioner questions about project construction. Construction periods, when settled solids are removed from the ponds and placed in the dry storage area, will never last more than 6 months, though GP anticipates a more likely timeframe is actually 3 to 4 months each time. Construction phases will occur roughly 10 years apart during the 50-year project timeframe. GP will also continue its current maintenance of the wastewater treatment ponds between phases, which includes removing the solids, also referred to as dredging, from the wastewater treatment ponds and placing them into the 15 and 30-acre ponds approximately every 3 years, which occurs today. This maintenance activity is ongoing and will not be impacted by the project. The initial construction will involve draining both ponds and preparing the solid storage area. Solids will be removed from the settling ponds, dried, and stacked in the storage area, and GP will then plant grass on the area to control erosion. Each later phase will involve draining the 30-acre pond, removing wet solids, drying the solids, placing the dried solids on the storage area, and replanting with grass. This rendering depicts the solids area as covered with grass. Commissioners also raised concerns about whether the project is suitable for the site. The question of suitability must evaluate the difference between the existing use on the site and what is proposed. Here, the exact settled solids material that exists in the 15-acre pond will still be placed in that same area. The only difference is that the material is wet today, but will be dry after the project is completed. We recognize, however, that seismic hazards at the site, which are present along the entire Oregon coast, combined with the site's proximity to the river, raise suitability concerns for the Commission. I'm now going to turn this over to Don Dotson with Wood to discuss the additional seismic analysis we conducted and the mitigation we are proposing to ensure the settled solids will not enter the river, even during a catastrophic Cascadia earthquake event.
Thank you, Allison. Let's talk a little bit about the geotechnical and the earthquake and seismic parts of this project. So we've gone out and we've done some exploration, we've conducted lab tests, we've done analyses, and we've broken the project up into 3 reaches based upon the subsurface conditions and also based on the geometry of the berm at these particular locations. So we've broken it up into reach 1, reach 2, and reach 3. And then we've looked at the seismic events that are likely based upon the geology of the area, specifically the Cascadia magnitude earthquakes. For this particular project, most of the project will be in the area of reach 1 and reach 2, but we went ahead and evaluated reach 3 as well, just for completeness. So let's take a look at the geometry of the project. So here we have a view looking upriver to the west, to the east. And notice that out here in the river, we've got a sandbar. And we've got the toe of the berm down here at the about the same elevation of the sandbar. It goes up at a inclination of about 3 to 1, something like that. And the distance from the toe of the berm where it meets the river and the top or crest of the berm where the road is about 70 feet. And then this is important. We've got a buffer zone that's about 75 feet from the top of the berm out to the toe of the proposed solid area that it's already existing, but we're going to be adding to it. And from there, going up to the crest, we're at a little bit over 200 feet. And the important thing about this particular geometry is that the crest of the solids is far enough away from the berm that it really doesn't have an impact on the stability of the berm. So let's look at some of these reaches and get into some more detail about what the earthquake could be doing to these particular berms. So we looked at 3 different earthquakes, all Cascadia events. We looked at an event that would be a fairly small event, 7.76 magnitude earthquake, all the way up to a full Cascadia 9.1 event. And we have different return periods for these earthquakes. A return period is the amount of time that you would expect in between these events to occur. So for example, a 250-year earthquake would be the size of earthquake that you would expect once every 250 years. And the same all the way up to the 2,500-year earthquake. That's an earthquake that you would expect to happen at least once every 2,500 years. So when we evaluated the displacement of the berm, and this is the actual vertical displacement, how much the berm would drop during a earthquake of the magnitude that we're looking at, we see that for a small earthquake, the 250-year earthquake, we only have about 1 inch or less of vertical deformation, and that's not really bad. And it stays pretty low all the way until you get up to the 2,500-year earthquake, where the deformation in the vertical direction up and down is about 2.2 feet. Now, this is not a particular problem because the distance between the top of the solids and the top of the berm is over 3 feet. 3 feet's the minimum that we have. And so a deformation of a couple of feet is not a problem, especially because the solid material that we're containing behind the berm is dry. There's no liquid that can leak out and actually damage the berm or cause a breach. And it's both stable in its current condition and also during the maximum earthquake that we would expect it to ever see. Reach 2 is very similar. The full Cascadia event, the 2,500-year event, has a little bit more deformation all the way up to 2.6 feet versus 2.2. But still, that's within an acceptable limit, given that the amount of freeboard, the distance from the surface of the solids up to the top of the berm that we have, not a problem. But if we go to section 1, section 1's the least stable and has the worst subsurface conditions that we observed when we did our exploration. And so the 2,500-year event has a deformation of all the way up to about 6 feet. This is a little excessive, and so we're probably going to have to do some mitigation to take that into account and fix that. So let's talk a little bit about the different methods that we can use to mitigate this problem. So here's a cross section that shows the solids, the berm, and then this circular line here that goes all the way out to the river is the most probable line of deformation or line of weakness that we have in the soil. And so this is where we would expect to see a rotation and a displacement of a couple of feet as the earthquake hits. So the way to mitigate that is to insert these structural elements here. And I'm showing 3 just for illustrative purposes. We would have to determine the exact number by doing the full design. We intersect the failure plane and we cut off the ability of this particular rotational area to actually rotate during an earthquake event. So here's the method that we do. We're going to use a technique called vibro compaction. Sometimes it's called vibro replacement. There's lots of different variations on this one particular construction technique to improve the strength of the ground. And we'll do this in accordance with the Oregon Department of Transportation seismic mitigation guidelines. So let's run a little film here, and I'll talk about it as we go through. It shows how this works. So we have a piece of equipment. This is a crane, and the equipment that's being lowered into the ground is called a vibro flot. And the vibro flot has an eccentric motor in there that causes it to vibrate at a high frequency. And as it's lowered into the ground, it actually pushes the soil out of the way. And then they bring in additional soil, in this case, sand. And the sand is allowed to drop into the hole. The vibro flot will go back down and strengthen the sand, and it'll improve the ground and actually prevent the rotation and the deformation that we've been discussing.
Thank you, Don. We are planning to include this seismic mitigation as part of the project, but recognize that the Commission may wish to condition the project's approval on this mitigation being completed. We would accept a condition of approval setting a maximum deformation for berm reach 1. We've included language for a proposed condition of approval in our written materials and also shared this with county staff. So finally, we want to address questions about the potential for odors, dust, noise, and visual impacts from the project. Regarding odors, the settled solids are composed of wood and paper particles. As is true for all organic materials, the solids can produce odors when they're disturbed. The project has the potential to emit odors as the solids are removed from the ponds and relocated to the storage area during construction. This potential for odor already exists every 3 years when the solids material is removed from the wastewater treatment ponds and placed in the 15 and 30 acre ponds. The mill notifies residents when this maintenance activity occurs and encourages citizens to notify the mill of any odor concerns. The mill maintains a 24-hour call-in number for mill-related concerns of any kind, which will be maintained. If odors occur as part of this project, GP will treat the material with BioWish odor control, a biologic designed for odor treatment of the types of solids found in the ponds. Regarding dust, GP does not anticipate this project will create dust since the settled solids are wet and once dried will be planted with grass. However, construction vehicles may create dust coming to and from the site. GP uses water sprayers to control dust for all of its operations and will utilize these for the project as needed. Regarding noise, the project's construction phases, which will last 6 months or less and will occur approximately every 10 years, will require construction vehicles. However, it's important to note that even if the off-site hauling alternative was chosen instead of the project, which would not require approval from this commission, construction vehicles would still be needed. But that option would also add significant traffic noise. Since we cannot eliminate construction noise, GP will agree to limit construction equipment use to daylight hours only in order to further control the time period during which project noise is present. Finally, some concerns were raised about visual impacts. We do not anticipate view impacts from the project due to the existing barriers and natural topography. We put together some slides showing homes in various areas and how these existing features ensure the views are not impacted. An existing row of trees shown here blocks views of the existing landfill area and will also block the project site from the homes in this vicinity. Homes in this area are shielded both by the trees and an elevation difference. The homes are at a higher elevation than the project, which further obscures the view. We also captured views from nearby individual homes near the site. This photograph shows the view from the home at 327 South Bay. This home, like others in its vicinity, is shielded by existing trees and the home is at a higher elevation, which obscures the project from view. This photograph shows the view from a home which is similar to others in its vicinity. The project is obscured by trees and the home is at a higher elevation, further blocking views of the project. Finally, there are several homes located across the river from the project. Views from this area are at grade. Although screening isn't possible because it could compromise the integrity of the berm to plant trees in that area, the view itself from these homes will not change significantly with the project. The settled solids will be terraced and appear almost identical to the view today, but with added grass cover. In conclusion, thank you for the opportunity to present this information. We hope we've helped answer your questions, and we also urge you to review our written submission, which includes responses to all questions during the last hearing. We've spent many months analyzing all available options, and we firmly believe the project is the best solution for all concerned, the community, the company, and the environment. We urge your support and welcome any additional questions you might have.